In this video, I'll be working through the question you can see on the screen from the Cambridge A-Level Maths Paper 1. Specifically, it's Paper 1-1 from the winter exams in 2023. If you're looking for a different question from this paper, there should be a link to a playlist with all the questions below this video. I'm doing this on a whiteboard. Hopefully it'll be like you're used to your teacher doing. And if you do find this or any of my other videos useful, I'd greatly appreciate it if you like, subscribe, or even share it with a friend that's doing the exam this year or next. In question 9, we're going to start off relatively simple. We're going to be rearranging a quadratic formula, and then we're going to be dealing with a lot of functions, a lot of theories around functions, the ranges of the functions. We're going to be getting the composite of two functions together, and how does that affect the ranges. Quite complicated questions. So let's start off with part A and we'll get to the harder stuff then in part B. In part A, they give us this function here and they ask us to put it in the form of, let me write it up here, 2x plus a, that's just plus something, plus a constant b at the end. So basically there should be a number here and they tell us, yeah, it's just a constant. They don't tell us it's an integer or anything, but it does work out to be an integer. So yeah, we can rearrange, look at this. This is a very common and standard thing to do. It's called completing the square because there should be a square right there. And we can use this to solve quadratic equations, even difficult quadratic equations. So a lot of students like using this in many times over the exams. But it's also useful when looking at the ranges of a question, which we'll see later on. Okay, so how do you do this? First, if we multiply this out and see what it would look like, it would look like 4x squared. We get 2x times a, which would be ax, 2ax, and another 2ax. So we get 4ax, and we get a squared plus b. Now they're saying this should look like this. And it does. The 4x squared already works. 4x squared. The problem arrives when the second number, the number with an x in it, this has a 12. And this isn't a 12, this is 4a. But hopefully you can see now, if a was minus, let me just double check that, yeah. If a was minus 3, 4 times minus 3 is minus 12. So minus 3 would work here. Minus 3 up here would work. So let's pretend it was minus 3 and we'd get 12x here. But if a was minus 3, this would be a 9. So that's a problem. 9 is not 13. But it's okay because we have something to fix it. That's what this b is doing. It's fixing the cheat or the mistake you're making in here. So the b fixes that. So what does b have to be to make all this work? Plus 4. So this is it's a type of question you get very used to doing this, doing exactly what I did, but mostly in your head. You know the term here just has to make this work, this one work. And that's where you get the minus 3 from. Then once you get the minus 3, you work out what would be here. And you can do a lot of this in your head. You work out what would be here and think to yourself, what fixes this to make it look like this one? That's where all these come from. So again, this guy, put a bracket around him, he shrinks back down to 2x minus 3 squared plus 4. That's where I was getting that from. This guy becomes this here. That's it for part 9. And you can use this for any quadratic equation because when it equals 0, it makes everything a lot simpler because we just have 1 squared. You can move this over, square root both sides. In this case, it won't work because the solution to this equation, it doesn't have any roots because it's a minus 4 would move over. Anyway, that's not important for this question. Okay, let's go on to part B. Okay, in part B, it gets a lot more complicated. They tell us there's a function f that's defined as the same thing they already gave us, which means, remember to use part A. Instead of using this function here, I'm always going to use this one here because they did that for a reason and that makes it a lot easier. So they gave us this function's f. And then they tell us there's a function g. They tell us g is only, I'm losing it here. Let's see, g is only defined when x is less than 8. So the only things you can put inside g is numbers that are less than 8. So that's very important. Then they tell us fx is only possible between p, sorry, not equals, no equals there, between, p and q. Between p and q. And this one is x is less than 8. And then one last thing, they tell us it is possible to form a composite function, gf. And remember what gf actually looks like. Another way to write gf is g with fx inside it. So there are all the clues we have here, and they want us to find not the value of p, the least value of p, the lowest possible value of p, and the greatest possible value of q. A bit of a spoiler later in the question, we're going to end up getting out two numbers here. X is bigger than and less than two numbers. And it's going to look like I'm just saying equals. P equals this and Q equals this. They did that on purpose just to, if anyone got to that part, they wanted to give them full marks. But technically correct, they had to say least possible and maximum. So don't get caught up on the least and the maximum there. I'll hopefully explain this better when we get to it. Okay, so the clues we have, they can be made a composite, and really x is less than 8. They're the biggest clues we have. And look what a composite is. It's something going inside G. And what did I say about that? Anything that goes into G has to be less than 8. And they're telling us f can go into G. So that means the function f, which is really this one here, 2x minus 3 squared plus 8. If it can go into G, then that means it has to be less than 8. And that was the trick in this question. That's the part you needed to notice. Like, feel free to pause the video. If you didn't get to this bit, pause the video and try and solve it from this point. Because that was the real trick here. To notice that this is less than 8. And you will get marks. 3 marks, you get 1 mark just for writing this line, I would imagine. I don't know, but I'm guessing. So we can go ahead and try and solve this. 2x minus 3 squared is less than 4. 4 just comes over. Let's see, we can get the square root of both sides. But that's where it gets messy. 2x minus 3 and plus or minus 2. I won't write a sign in yet, because lots of students, it gets messy here. You can draw functions for it, you can do different things. I just like to think it through. Something squared is less than 4. So let's just think through some numbers. Like less than 2, so you might write just less than 2 or something. And that's wrong, because yeah, sure, 1.5 squared is less than 4. 1 squared is less than 4. 0 squared is less than 4. Minus 1 squared is less than 4. But let's say minus 5. That's less than 2. And that is not less than 4 when you square it. Minus 5 squared becomes plus 25. So what you need to remember here is this breaks up. We get, when you get the square root, you actually get inequality both sides. And in this case it would be less than 2 and greater than minus 2. That's the function we would get here. We can go ahead and then solve this a bit as well. Let's add 3 out. We can do it. You can do 2 sums here, or you can do it all in one go, I think. Let's just add 3 both sides. We would get 2x would stay in the middle. Add 3 here, we'd get 5. Add 3 to that side, we get a 1. Now we can divide everything by 2. We get a half here. We get x here, and we get 5 over 2 here. So have a look what this is saying. This is saying that fx that went in here, this function here, we knew it had to be less than 8. And now, just because of how the shape of the function is, we now know it is less than 8, but it also has to be bigger than a half and less than 2.5. And what they had told us is there were rules to this function that it had to be bigger than something and less than something. So it's very easy just to write in a half and 5 over 2, and that is the correct answer. But just to be very clear, there's lots of possible answers for p. Because remember, this is it's a whole separate rule to this one. This is a rule that comes about from the shape of the function. This is a rule they made up. They might just say, oh, it's only defined between 1 and 2. They could easily say that. And 1 and 2 fits into this rule. So that does work. And that's where the minimum and maximum. The smallest possible number that they could have said that this function is defined on is a half. Because they never could have told you this was 0. This function is defined between 0 and 2.5. Because it's not. It can't be defined as low as 0 because of the shape of the function. Now I hope that's clear. I think that's a bit beyond the level of this course, to be honest. Which I think the examiner would be very lenient on the marking here. And it's why they made sure that this looks a lot like here. Just so many students would just write P equals a half and Q equals 5/2. Because that's technically correct. I just wanted to say a few words about that. For example, if they hadn't said minimum and maximum and they said give a possible value for P, well, P could have been 2 and Q 2.4. You know, that would have worked. P could have been just bigger than a half and Q could have been a little more bigger than a half. Just to draw this out, this is a half and 2.5. Again, the shape of the curve tells me the answer has to be in here. But the rule they gave, P and Q, could have been anywhere in here. Once it's dead in this world, just said the minimum is here and the maximum is here. But they could have easily said here and here or something. Right, I hope I've explained that. Let me clear this off and we'll do the next part. Okay, in part C, they want us to find the expression for this composite here, the GF of x. And again, GF of x can just be wrote as, well, GF, or it can, well, the function is GF. GF of x can be wrote as G bracket fx. And that's how I rather write it, because it seems a lot clearer what it is. So how do we do that? We take gx first, and that's 3 multiplied by something plus 1. That's what gx is. Something's an x, but it's not an x in going into the gx. It's a whole function. It's f of x, which is this whole thing here. But again, can be wrote as just this. I don't think I've left enough room still though. 2x minus 3 squared plus 4. That's what's going into that function. So we can just multiply all that by 3. We will get 3 times 2x minus 3 squared. 3 times 4 is 12. But we'd also be adding 1 onto it. So we get plus 13. So it's just, we're getting this whole new function. And yeah, that's it. That'd be fine as an answer. Just one moment, even though I think this is fine, again, there's only 1 mark, so it should be fairly quick. I think this is fine. The answer in the marking scheme does have this multiplied out, which is 4 times 3 is 12x squared, 6, 12, 36 minus 36 x's. Let's see, we get 9, we get 27, plus 27, 37, 40, plus 40. This is all, both of these should be full marks. But still, I thought I'd put that there because I think we're going to use this for part D. No, actually, no, we're not. Okay, so part D. Part D then asks us, they say H is, H is defined by this function up here, the same one, 4x squared minus 12x plus 13 for x less than 0. So yeah, we'll use this same rewriting, except we'll just put x less than 0 there. And they want us to find an expression for the inverse. So the inverse of this guy here. So let me write that guy out. Y is equal to 2x minus 3 squared plus 4. So we're not going to use this one like they told us. We're going to use what we rearranged it as in part A. So we're going to find the inverse of this. To find the inverse something, I just switch the x and the y. And in this case though, I'm going to do that later because we're going to get into a problem with the x's. So before I switch these around, what I'm going to do, I'm going to rearrange it so it's x equals. And then I'll rearrange it, and then switching the x and the y is basically inverting it. Yeah, I've never really explained this one well, and I don't think I ever will, but this is how you do it, which is mostly all you need to know. So basically we're going to rearrange this to get x on its own. So let's just start moving things. Move the 4 over. Y minus 4 is equal to 2x minus 3 squared. Let's square root both sides. Plus or minus will appear over this side when we square root it. This will become just here. Let's add 3 to both sides. We get 3 plus or minus square root of y minus 4 is equal to 2x. Let's divide both sides by 2 and we get this. X is equal to that. Now here's where the x less than 0, this is where you're going to lose 1 mark or not lose it depending. They tell you x is less than 0. Square root of a number has to be bigger than 0. 3 is bigger than 0. So how could this be a minus? If it can't be a minus with a plus here. 3 plus a plus plus a plus, as a positive number plus a positive number divided by a positive number cannot make a minus number. And we know x is a negative, so that plus can never be there. Okay, now you should rewrite it again, show the examiner you're taking it away. Actually, it doesn't matter. Once you take it away. So this is x can only equal this part. So the inverse function is just switch them around. We got a y, put a y where the x is. I'll put the equals this side, just looks better. Equals 3 minus square root of x minus 4 over 2. That's the inverse function of this. Let me just check that on my notes. Yes, 4. Okay, so that's the inverse function of that question. So just to recap what I do, to get the inverse of a function, you just rearrange it so the term you're looking for, the x term, is on its own. But then we don't leave it like this. I think you should get full marks for writing something like this, probably. But it's not common to put x out front. Right? It's only a convention that we have y and then x's. But let's stick to the convention. It's the convention your examiner knows. It's what we should be using. So just change the x and y's, basically. Or you can, instead of y here, you can put in h, the inverse h of x. If you wanted to leave y here, I guess I personally would accept as a full answer the inverse h of y. That's a perfectly correct answer, and it's perfectly correct terms. It's just not that common of a way to write it. Okay, I hope I haven't confused you there at the end. Basically rearrange it and you found the inverse. Okay, thanks for watching the video. If you have any questions, let me know in the comments below. Have a great day.